This Zoom session is being brought to you by the Fractal Black Rose. Okay. Today we will be discussing radical expressions and functions 7.1 and section 7.2, rational exponents. We start with square roots. We start with a square. Okay, here's a square. It has an area, call it A. It has a side, or for some reason it's called a root, S. And the area equals S times itself, S to the second power, S squared, because that's a square. Now, okay, that gives A in terms of S. The question is, what is S? I'm given A, what's S? It's the reverse question. Well, this is called the square root. You see this kind of funny R shape covering the A. Unfortunately, this notation is kind of open on the right, so you don't want to put numbers to the right of a square root unless you want to be inside of it. It's a potential confusion. All right, now, square root of A is a solution to root A squared equals A. Now, turns out there's two solutions, root A and negative root A. I mean, so for example, the square root of 4 is 2, because 2 squared is 4. But negative 2 squared is also 4. So root A is given as the positive solution. So for various values of S, 0, 1, 2, 3, S squared will be 0, 1 squared is 1, 2 squared is 4, 3 squared is 9. Now, running it backwards, what is the square root of 0? Well, 0. What is the square root of 1? 1. Let's just flip this around. What's the square root of 4? 2, because here's a 2, 4. But what's the square root of 2? What number times itself is 2? Well, if you have a calculator, or you can use the access the calculator function on your phone, then you can find out that it is approximately 1.414213562. Square root of, this should be a 3. Excuse me. 7113. Okay, that's approximately 1.732050808. These all go on endlessly. And what's more, unlike a ratio, like 2/7 or 5/13 or whatever, those eventually settle into an endlessly repeating pattern. These do not. These do not settle into a pattern, because the square root of 2 and the square root of 3, and in fact the square root of anything that's not itself a complete square, is not a ratio of integers. It's called an irrational number. Maybe sometime I'll tell you about how the Pythagoreans ran into this, and it literally drove them crazy, because they thought that all numbers were ratios of integers, and they just couldn't handle something like that. Nowadays, you can push a button and get it to as many decimals as you want. They couldn't handle that. They didn't have decimal notation or Newton's method. But we proceed. Pythagoreans were a really interesting bunch, by the way. All right, now, if A is P squared over Q squared, then its square root is P over Q, a ratio of integers. If it's not the square of a rational number, then it is not a ratio of integers. It's an irrational number. And if A is less than 0, then we cannot define the square root of A on the real number line. The reason for that is that if you square a positive number, you get positive. Square a 0, it's 0. Square a negative number, it's positive. And in none of these cases do you get a negative. So the square root of -1 is neither 0, positive 0, nor negative. You'll have to create in fact, there has to be a whole new system of numbers called complex numbers, which we may get into towards the end of the course, and about which we have there's an extra credit set in the extra credit module. In general, the square root of x squared is the absolute value of x. Absolute value, because this square root is always a positive number. So square root of -2 squared is the square root of 4 is positive 2. So we throw in this absolute value, which complicates things a little bit. All right, we proceed. 3. To graphing y equals the square root of x, you get this upper half of a sideways parabola. I mean, if you drew y equals x squared, you get a upward pointing parabola. This is half of that parabola tipped on its side, because basically x and y exchange places. Now, the cube root function, that's related to the square root function. It's a number which, when cubed, gives you x. Now we don't have to worry about absolute values or or negative numbers. This works fine because cube is a lot nicer for signs than squaring is. So the cube root of x, that cubed, is the cube root of x cubed, is x. So sort of the cube root is the cubing, and square root is the squaring, the inverse function. Its graph looks a lot like the square root graph. Well, a little bit flatter actually. It's kind of an S-shaped curve like this. It's defined for negative numbers. In fact, the cube root of negative x is negative cube root of x. It's what's called an odd function. Nth roots, well, it's the solution to nth root of x to the nth equals x. So there's fourth roots, fifth roots, sixth roots, and so on. If n is odd, then the nth root of x to the n is x. If it's even, then the nth root of x to the n is the absolute value of x. We get the same thing with even numbers. Squaring makes positive and negative both positive. So you have to have this square root sign, this absolute value sign, excuse me. So we have some examples. Square root of 1/9, what's that? Well, 1/3 squared is 1/9, so the square root is 1/3. Is the square root of 0.25, which is square root of a quarter. And a quarter is a half squared, so the square root of a quarter is 0.5, 1/2. Here we have the square root of 36x to the 6th. Now we can rewrite this. 36x to the 6th is the square of 6x cubed. That's because 36 is x squared, and x to the 6th is a cube squared. And then the square root and the square cancel out, and you get 6 absolute value of x cubed. I'll put in absolute value because x cubed could be negative. 144 m to the 8th, well, square root of that, well, 144 is 12 squared. M to the 8th is m to the 4th squared. And the square root and the square cancel out. And I write 12m to the 4th. Well, actually, I don't need an absolute value sign because a 4th power is always positive anyhow. In general, if you have a square root of a product, that's the product of square roots. And the square root of a power is a to half that power, if n is even. Actually, it works for odd numbers, and we'll get to that in the next section. But in any case, as you can see, a square root of a 6th power is a 3rd power, a square root of an 8th power is a 4th power, and the square root of an nth power is an n-half power. All right. Here we define a function, square root of 3x plus 1. What is it value at 8 and at negative 2? Okay, f at 8, plug in 8 in for x, 3 times 8 plus 1, root 24 plus 1, root 25, and 25 is 5 squared, so the square root cancels that, and you get a 5. Plug in a negative 2, 3 times negative 2 plus 1 is negative 6 plus 1, square root of negative 5, but that negative means that the square root is not what's called a real number. Now let's try cube root of 64 s to the 9th t to the 6th. What is that? Well, 64 is 4 to the 3rd power. X to the 9th is s to the 3rd power. T to the 6th is t to the 2nd to the 3rd power. It's simply because 9 is 3 times 3, 6 is 2 times 3. And the cube root and the cube cancel, and you get 4s cubed t squared. Here we have the square root of 400 m to the 16th and to the 2nd. Well, 400 is 20 to the 2nd. M to the 16th is m to the 8 to the 2nd, because 8 times 2 is 16. And n squared is n squared. Square root and square cancel out. 20 m to the 8th absolute value of n. I put an absolute value because to make sure that this is positive, and the square root of the square is always positive. Here they ask for 121, 8, a and b, ask for the square root of 81 and the 4th root of 81. Now 81 is 3 times 3 times 3 times 3, or 9 times 9. Okay, so root 81 is 9 squared, square root and square cancel, leaves a 9. 9 is 3 squared, squared is the 4th power. So 4th root of 81 is the 4th root of 3 to the 4th. Again, these cancel and you get 3. Okay, that concludes this section.